Water balance is the most basic but most significant concept in hydrology. This video series discusses solutions to water balance problems. You are in hydrology. The first example simply provides parameters to be plugged in the water balance of a certain catchment area of 300 acres. The task is to determine the evaporation in a 30-day period. Precipitation is 1.3 inches. Surface runoff inflow is 15 cubic feet per second, while outflow is 13 cubic feet per second. The change in storage is 16 acre-feet, and it is also stated that infiltration is taken as 0. The water equation has the inflow volume less the outflow as the change in water storage. From the given parameters, inflow includes precipitation and also surface runoff inflow. The other parameters are considered outflow, like the surface runoff outflow, the assumed infiltration, and the required evaporation. Since we have already categorized each parameter, we can then place the values. Precipitation is 1.3 inches, and the inflow surface runoff is 15 cubic feet per second. On the other hand, water losses or outflow volume consists of 13 cubic feet per second surface runoff outflow, the infiltration, which is 0, and the required parameter evaporation. All of these are losses. That is why they are all minuses. Then close the equation by placing the change in storage, which is 16 acre-feet. With the different units of each parameter, all we can do for now is to simplify the surface runoff, making the equation 1.3 inches plus 2 cubic feet per second minus 0 minus E as equal to 16 acre-feet. With this shortened equation, isolate evaporation before any simplification, making E as equal to 1.3 inches plus 2 cubic feet per second minus 16 acre-feet. All we needed to do next is to align the units so we can simplify the values. In hydrology, the volume is also expressed as depth, as the catchment area is a standard parameter. So in this example, the precipitation volume of 1.3 inches is taken as it is. Moving on to 2 cubic feet per second. As we needed the volume of evaporation, these should be converted into inches like precipitation. To take out second, we multiply the factor of 3600 seconds per hour, where there are 24 hours in a day. Then multiply 30 days as given in the problem as time period. By doing this conversion, notice that time is cancelled out in the expression. Next is to deal with the cubic feet unit, and since the area is given in acres, we multiply the factor of 1 acre is to 43,560 square feet. Then divide the catchment area given in the problem, which is 300 acres. This will cancel some more units, leaving feet. So to be with the same units with the first term, we then multiply the conversion of 12 inches as to 1 foot. The second term then can be simplified as 4.7603 inches. The last parameter is the change of storage, which is 16 acre-feet. Take out acres by dividing the surface area, which leaves us with feet. Then multiply the conversion of 12 inches is to 1 foot, cancelling out feet and leaving only inches. The third term is converted into 16/25 or 0.64 inches. Summing up all terms, E is taken as 1.3 plus 4.7603 minus 0.64 inches, making E as 5.4203 inches as the monthly evaporation of the area.